Hello everyone, welcome to another webinar for developers on REST API for Bitrix24. Today I'll delve into a rather specific topic, offline events in REST API. This is a highly useful mechanism for obtaining information about changes in data within Bitrix24. As you know, with the REST API you can register event handlers in Bitrix24. For example, events like adding or updating a deal, deleting contact, and so on. Bitrix24 offers a wide range of possible events, and incorporating event handlers in your applications allows you to implement diverse business logic. For more information on the topic, I recommend checking out these lessons in our video course. You might remember from our previous lessons that an event handler is registered using the event bind method. Typically, you need to specify several parameters, such as the event name, and the handler, the URL of the event handler on your application side. In a regular scenario, when the corresponding event occurs, for instance, when a deal is updated, Bitrix24 will call your handler, passing information about the modified deal. This enables your application to react to changes in Bitrix24 data almost in real time. However, this approach has several drawbacks. Firstly, you can't control the incoming load on your event handlers. If you subscribe to changes in deals, and suddenly 1,000 deals are changed in your CRM simultaneously, you'll receive 1,000 hits on your handler from Bitrix24 in a fairly intensive mode. Moreover, if the same deal is changed 1,000 times in a row for some reason, you will also get 1,000 hits on your handler. Managing such a lot might be challenging. This leads to the second drawback. If your server crashes and fails to process all events, Bitrix24 won't resend them. On our end, we just register that the application handler returns an error or doesn't respond, and that's the end of it. No second chance. If processing all events is crucial for your business logic, offline events come to the rescue. You can register an offline event handler using this same event bind method, but the parameters will differ slightly. Firstly, you need to specify the event type parameters as offline. Secondly, there is no need to provide the handler parameters anymore. This is because in this case it's not Bitrix24 that's calling your handler. Instead, your application will need to call Bitrix24 to retrieve information about the events that have occurred. Before we delve into details, we'll need another method, event offline list. It has several parameters, such as filter to select only the necessary events and order to sort the return data. I'll use this method to demonstrate how data about the events that have occurred is generated. We'll need to add a local application to our Bitrix24 or install a public application through the developer's account. We've covered how to install a public solution from the developer's account in our video course. For simplicity's sake, we'll use a local application based on our simple C-REST SDK, which we also discussed earlier in the course. In the example, we've used the file install.php, where the install app method is called, and the file index.php, where we simply output the contents of the request array to the interface. Upon opening the application, we receive the access token from the Bitrix24. I copy this value and paste it into the variable in Insomnia. This obtained token will be used for making REST method calls as if they are made from our installed application. Assuming you are familiar with Insomnia, a tool allowing you to execute REST requests with the necessary parameters, you can also use Swagger or Postman if you prefer. Let's start by registering a handler For deal changes, minion will call the event bind method with pre-prepared parameters. The handler is successfully registered. Now let's go to the CRM section in Bitrix24 and modify a couple of existing deals. Returning to REST, we execute the event offline list method without any parameters. You can see that two events for these modified deals have been registered in Bitrix24. For each event, we can see what type of event it is, when it occurred, and obtain the specific identifier of the modified deals. Let's conduct a small experiment. Going back to CRM will change the first deal. Then we execute the event offline list method again. We still see information about only two deals, even though the date and time of the update for the first deal have been changed to a later timestamp. Regardless of how many times we modify the same deal, it won't add new offline events one after another. Instead, it updates the existing information. If the same deal is updated 1000 times, there will be only one record in offline events indicating which deal was modified. So what's the significance of offline events for applications? The key purpose lies in their predominant use for data synchronization tasks between Bitrix24 and an external system. Such tasks often don't require real-time updates. There is no need to react to every change for these tasks. What's crucial is that when your application communicates with Bitrix24, you precisely know which Bitrix24 objects have been modified, added, or deleted since the last interaction between your application and Bitrix24. Even if the same deal has been modified 100 times, for synchronizing that deal with an external system, you only need to take the current, up-to-date state of the deal at the time of synchronization. This is precisely why we don't log every change of the same object in the offline events. It significantly simplifies the development of your applications. How should the workflow with offline events be structured? At regular intervals, your application should request the list of occurred events. Subsequently, using regular REST API methods, the application should obtain up-to-date information about modified objects and transmit the updated data to the external system and so on. Most importantly, at the final step, the application should notify Bitrix24 that these events have been processed by the application, and there is no need to store information about them anymore. If you neglect this step, each time you access the list of offline events, you will accumulate it to more and more stored events. So we've come to a very crucial method for working with offline events, namely event offline get. It has the most important parameter, clear. I'll explain it a bit later. For now, let's proceed with a small experiment. Let's execute the event offline list method to make sure we still see information about the events. Now let's perform the event offline get method. It returns the same result. So what's the difference? The key difference is that it not only provided us with information about the accumulated events, but simultaneously removed these events from the list. If we now call event offline list, we'll see that the events list has become empty. The event offline get method not only allows us to retrieve information, but also informs Bitrix24 that the received events have been processed by the application, and there is no need to report them again. Using event offline get, you can process all the accumulated events by fetching them in batches of 50. The method's operation is optimized for use in asynchronous mode. This means that each parallel call to event offline get will reliably receive this event without overlapping with other events, regardless of the intensity with which you request this data. However, the approach with automatic clearing of the event queue has a significant drawback. There may be situations where your application made a request to event offline get, but for some reason, due to memory overflow, network issues, etc., it did not process these events. However, on the Bitrix24 side, information about these events has already been deleted and cannot be restored. To guarantee the processing of all offline events, you can call the event offline get method with the parameter clear equals 0. In this case, the package of returned events will not be deleted in Bitrix24. Instead, it will be marked with the unique identifier process ID and hidden. After processing the received events, the application itself must notify Bitrix24 that these events can be deleted. To achieve this, the application must call the event offline clear method, specifying the parameter process ID, the unique identifier obtained when calling the event offline get method. Optionally, you can also specify the parameter message ID as an array of identifiers for specific events that need to be deleted. This allows, if necessary, to clear not the entire package of events, but only part of it. So, the most complete logic for handler offline events looks like this. The app asynchronously requests offline events packages using the event offline get method with parameter clear equals 0. The app can save the received data, including information about the package's identifier process ID, in its database and then process it. This might take some time. Once the processing of these events is done, the app informs Bitrix24 that the data for these events can be removed from the queue by calling the event offline clear method and passing the package identifier. And so it goes in a loop until all events are processed. Let's see how it works. Go to the CRM section, make some changes to a couple of deals, go back to REST and check if the change events have been recorded by calling event offline list method. Now let's call the event offline get method with the parameter clear equals 0. We get information about two events and pay attention to the value in the process ID parameter. We'll need it later. However, these events are only hidden, not removed from the queue. We can confirm this by taking the process ID value and putting it in the corresponding parameter of the event offline get method. As you can see, when given the identifier of the specific package, Bitrix24 returns the hidden events to us again. So it's crucial to keep the process ID value on the application side. It's the only way to access already hidden events. Imagine that our application has processed the received events, and now we need to inform Bitrix24 about it. Call the event offline clear method, specifying the necessary process ID value. The data in the event queue has been cleared. We can confirm this by checking the event offline get method again with the known process ID. As you can see, we got an empty result, as expected in this situation. I hope the demonstration wasn't too complicated. Now let's delve deeper into the possibilities of offline events. Imagine this scenario. Your application receives a deal change event, then requests the current deal information using the relevant REST API method. After that, it wants to modify the deal in Bitrix24 based on its business logic. To do this, the application uses the CRM deal update method. In the case of regular online REST events, as soon as the application calls the CRM deal update method, Bitrix24 immediately sends the onCRM deal update event to the handler registered by the application. This creates a closed loop, where a deal change on the Bitrix24 side triggers the handler in the application, which modifies the deal data in Bitrix24, triggering the handler in the application, and so on. Handling in a situation like this requires specific conditions in the application. When it comes to offline events, you can avoid the loop. To do so, when registering an offline event handler, you need to specify the auth connector parameter. This essentially creates a separate queue for offline events tied to a specific data exchange channel between Bitrix24 and the application. Then you should use the same parameter if you want to modify data in Bitrix24, but ensure that this change doesn't trigger another offline event. The easiest way to illustrate this is with a live example. Let's register a new handler for offline events specifying the auth connector parameters. Go to CRM and make a change to a deal. Let's retrieve this event using the event offline get method, again specifying the auth connector parameter. We already know that after such a call the event has been removed. Let's say our application wants to modify the same deal, for which we just received the change event. To do this, we'll call the CRM deal update method. The deal has been updated, and we can confirm this by checking the list of deals. Now let's make sure that the change event for the deal did not reappear. This is the essence of using the auth connector parameter. Call the event offline list method with the auth connector parameter. Indeed, we see that the list of events is empty. The whole scheme with the auth connector parameter is designed so that when your application modifies data, it informs Bitrix24. Don't notify me about the changes that I myself initiated. The takeaway here is, if you're using the offline events mechanism in Bitrix24, all modifying requests from your application should be executed with the auth connector parameter to avoid unnecessary events. This will take a lot of weight off your shoulders. I just want to add that, as of now, this parameter is supported in Bitrix24 on the Pro plan and above. Please keep this in mind during development. I've talked a lot about the advantages of offline events, but you should also understand the downsides of this approach. Firstly, unlike regular events, where Bitrix24 itself triggers your handlers, with offline events, you'll need to create a mechanism that periodically calls Bitrix24. This can be a non-trivial task, especially for mass-market applications installed on hundreds or thousands of different Bitrix24 instances. Secondly, because your application will be using REST API to retrieve new events, it will be subject to the usual rate limits and total execution time constraints imposed on API calls. You can learn more about these limitations in the documentation. The main takeaway is that for your application, getting offline events may take more time compared to regular online events. However, there is a clever feature that somewhat combines the benefits of online and offline events. It's called the special events on-offline event. By subscribing to it in the usual way, setting up your handler on the application side, you'll receive calls to this handler when new entries appear in the offline event queue. In the min timeout parameter, you can specify timeout in seconds. In this case, your handler will be called only if the specified number of seconds has passed since the previous call. The setting is handy if you don't want your application to receive signals too frequently, especially when there might be too few accumulated offline events. So, on one hand, your application automatically receives a signal from Bitrix24 that it's time to fetch offline events. This means you don't need to create a scheme for periodic calling of Bitrix24 on your own. On the other hand, you can independently retrieve the events you're interested in from the offline events queue with all the advantages of this mechanism that were mentioned today. So let's sum it up. Register event handlers with the option event type equals offline to independently fetch events later. Retrieve event packages asynchronously using the event offline get method. It's advisable to call this method with the parameter clear equals 0. To clear the queue only after successfully processing received events. Clear the queue using the event offline clear method. Use the auth connector parameter to avoid unnecessary cyclic events. And utilize the special online event on offline events to promptly receive signals about new offline events. We've got more exciting topics ahead, so stay tuned and join the Bitrix24 REST API Developer Telegram channel where you can connect with other developers and me.